Hello. In this video, we're going to look at a minimum-maximum problem, sometimes called an optimization problem. So let's take a look. A box has a square base and no top. The total area of the sides and the base of the box is 48 centimeters squared. Find the dimensions so that the box has maximum volume. Now, before we get going with the actual math here, we're going to want to draw a picture to help us understand what's going on. We've been told that there is a box, so we should draw some type of box. It has a square base, and we've been told that it has no top. Now, there's many ways to do this. One is to kind of draw it like that so you can see inside. Another way is to simply just draw an arrow and say no top. Okay, we have our picture, and we should give it some labels, some dimensions, so we can start to do some math with this question. We're told that it has a square base, and so whatever we label this dimension here, this one should also be the same letter, because we're assuming that this length and this length, even if maybe they're not drawn the best to scale, we're assuming that these two lengths are equal to each other. And now that we've labeled this, we should probably label the height as well, maybe with a letter H. Okay, so what are we trying to do in this situation? What do we have? Well, we're told some stuff about the area and the sides, but really we're supposed to find the dimensions so that the box has maximum volume. And so we want to start there. This is our main goal, to find the dimensions so that we have maximum volume. Now, the volume of our box will be equal to x times h, or simply x squared h. And this is the quantity that we want to maximize. We want to find the largest possible volume given the conditions that have been told to us. Now, if we were to find the maximum, the way we would normally do that is take the derivative. But unfortunately here we have two variables, and so we can't take the derivative like we normally would, because we need this to be just one variable. We don't want this to be v, we want this to be kind of v of x. We want it to be a function of only one variable. So we need to introduce some more equations based on what we've been told, and we know that the total area has to add up to 48 centimeters cubed. So the surface area has to add up to 48 centimeters cubed. Centimeters squared. Now, do we have a formula for surface area? Well, we could create one. We're going to have the base, so x squared, and we're going to have four sides. Each one of those sides will be the same. It will be x times h. And we don't have any top because we've been told that the box doesn't need a top. So this will be equal to our 48. Now, we need to somehow combine this equation and this equation, and there's many ways to do that. You could say, oh, there's an x squared here, I could plug that in, but unfortunately that would give me another xh, and so that's not really the best method. Really what we want to do is say, well, there's this h here and this h here, so if I can isolate for this h, I'll be able to substitute it in so that there's no more h left in my equation. Let's take a look what we can do. The x squared can move over to the other side, giving you 4xh equals 48 minus x squared. We can divide both sides by 4x, so that h equals 48 minus x squared divided by 4x. From there, we can take this h and substitute it in, giving us volume is equal to x squared times 48 minus x squared over 4x. Before we do the calculus, we should definitely simplify. There's an x here that will cancel. And we can multiply in, so we have v equals 48x minus x cubed all over 4. And if we wanted to go further, we could break each one up into an individual term. So we have 48x over 4 minus x cubed over 4. All right, so let's go ahead and actually take the derivative. So we'll have the following. V prime is equal to 48 over 4 minus 3x squared over 4. We can combine these to give us 48 minus 3x squared all over 4. And the 3 will factor to give 16 minus x squared over 4. The reason we're working on this is that we need to, once we found the derivative, actually do something with this derivative. We need to find its zeros, we need to draw its sign diagram, and we need to let that determine where the minimum, or in this case, maximum volume is. So we need to not just find the derivative, but we need to actually simplify and factor and draw the sign diagram. Now, let's take a look at what we have. 3 times 16 minus x squared over 4. That can be factored a little bit further. Doing so will give us 3, 4 minus x, 4 plus x, all over 4. Now, we're going to take advantage of the sign diagram here. So what we've been working with is actually v prime of x. And we can draw a sign diagram for it as follows. We have a 0 at 4 and a 0 at negative 4. If we pick a value bigger than 4, say 10, this will be negative, this will be positive. So overall, we're going to have a negative value, change the sign to positive value, and change the sign to negative value. So our function is decreasing, increasing, and decreasing. Now, the sign diagram again is important because if you look here, it's possible that there's some type of maximum volume occurring over here far to the left. Clearly it looks like the maximum could also be here, but it's possible that there's a maximum over here. And what we need to do is say, well, think about that x. X was the dimension of the base. Is it possible that x is negative 4 or even more negative? And of course the answer is no. We must have this. We must have x being greater than 0. And so anything over here, we can kind of imagine drawing a round bracket, putting a 0. Anything over here, it's all not valid. This stuff is not part of the domain. And so when looking at the sign diagram, we just want to focus in on this portion. What does it look like here? Well, it looks like there's a maximum happening at 4. And so we can then go ahead and say x equal to 4. This is going to be where our maximum volume occurs. We're almost done. They wanted us to find the full dimensions. So we need to remember that h is equal to 48 minus x squared over 4x, which will be 48 minus 4 squared over 4 times 4. So we have 48 minus 16 over 16. So that will give us 32 over 16, which is 2. Now, we started with a word problem, and so we need to finish in words. We need to make sure that we very clearly answer the question. The question, if you remember, was what are the dimensions of the box so that we have maximum volume? And so we can say the dimensions that give maximum volume are, and remember the x was both the length and the width because it was a square base, so we can say 4 centimeters by 4 centimeters by 2 centimeters. Thanks for watching.